Okay, 2015 MAT, question 2. So, expand and simplify that thing there. Okay, so many of us would probably have seen this product before, right? I mean, essentially it's just an minus bn, right? If you haven't seen it before, you could just expand it term by term and you realize that lots of terms cancel, which is the beautiful thing about this product. Yeah. So whenever, if you could write a number in terms of like, or if you could write an expression in this form, then it's always factorizable in this way. Always. Okay, always. Yeah, I mean, I'm not going to do the mathematics behind, but you just expand properly and then terms cancel out. Yeah. Oh, well, n plus 1, I suppose, here. Yeah. Because, you know, the first term is a times a to the n, which is a to the n plus 1. Okay, and the last term is minus b times b to the n. So that's minus b to the n plus 1. Alright? Good. So, first part's quite chill. Part 2. The prime number 3 has property that's 1 less than a square number. Are there any other prime numbers with this property? Justify your answer. Okay, so it's 1 less than a square number. Alright? So, now, that means that what sort of n do I have to put in? What sort of n do I have to put in? Well, I have to put in 1, right? Because I'm interested in, you know, it being square numbers. So now I consider a squared minus b squared. And I need b to be 1, right? Because I need to be 1 less. Well, or minus 1. Okay, I just need b squared equals to 1, I suppose. So I have a squared minus 1. What is that? Well, that's a plus 1. A minus 1, right? Okay, so for this thing to be, what is it called? To be prime, then one of these factors has to be 1. Right? Because if it has 2 factors which are not 1, then it's definitely a composite, right? Has to be, one of the factors has to be 1. So suppose that a plus 1 was the factor which was 1. Well, then if this equals to 1, then you're saying that a equals 0, which makes no sense. Yeah, this is, you know, rubbish. Well, if the a minus 1 equals to 1, then a equals to 2, which is actually the prime number 3. Right? So that means that there are no other prime numbers with that property in the question. Yeah. Manageable, I hope. Part 3. Find out the prime numbers that are 1 more than a cube number. Justify your answer. Okay, so let's go. I want 1 more than a cube number this time, so I want to consider the expansion a cubed plus 1. A cubed plus 1. What is that? So a plus 1 times a squared minus a plus 1. Like that. Okay, just by using part I. Okay, so I want this to be a prime number, i.e. either the first bit is 1 or the second bit is 1. Yeah? Okay, the first bit is 1 implies that a equals to 0, which is not correct, right? Because if I put a as 0, that means that I have 1. Well, is 1 a prime number? Well, it sort of was, but, you know, modern definitions of prime numbers excludes 1, okay? So I suppose the question doesn't want that answer. Okay, now, what happens if the second bit was 1? And now things get interesting, right? A squared minus a equals to 1. No, sorry. A squared minus a plus 1 equals to 1. I got slightly excited. Yeah, and then, so a equals to what? 0 or 1, and we know that a equals 0 is a rubbish solution. Yeah, is a rubbish solution. Okay, so a has to be equal to 1, which means that the only prime number, which is 1 more than a cube number, is what? Is 1 cubed plus 1, which is 2. That's actually quite an interesting finding. Okay, part 4. Is 3 to the 2015 minus 2 to the 2015 a prime number? Explain your reason carefully. Okay, well, so what can I do? So, I mean, the intuitive thing to do is that, okay, well, let's actually use part 1, right? The intuitive thing to think about is, let's use part 1. So, if I use it directly, then what do I get? Oh, I have 3 minus 2 times some rubbish, some junk afterwards. And you conclude that as prime. Well, is that a possible thing? Well, no, right? Because you don't know if this thing has more factors. Maybe it's just obscure that you can't see it, right? So this is not good enough. This is not good enough. Now, how about if I did something clever and I put something like, okay, what is 2015? 2015 is 5 times whatever, 403, right? So let's do something like this. We agree with that, right? It's the equivalent number, right? I just take powers. Okay, well then this, what expansion does this have? And multiply by some junk, right? Multiply, okay, let me get rid of it. Multiply by some junk behind, which I really don't care what it is. I only know that it's positive. And, you know, probably not 1. Positive and not 1, that's what I know. Yeah, then is that enough to say that this thing is not a prime number? Yes, right, because I have a first factor here, which is not 1, obviously, and second bit is definitely not 1, right, because, you know, the first number is already, like, what, 3 to the 403 to the 4, that's way bigger than 1, you know, and all the terms behind are positive, so it's just going to add up. That's why I know it's greater than 0. So, you know, it has 2 factors, which are not 1, i.e. it's not a prime number. All good? Okay, so this is quite a clever way of using part 1. Okay, last part 5. Is there a positive integer k for which k cubed plus 2k squared plus 2k plus 1 is a cube number? Explain your reasoning carefully. Okay, so let's consider positive integer k. Okay, what is its cube? Well, k cubed, right? K cubed. K cubed is the positive integer k. K cubed. Okay. What is the next cube number? Oh, intuitively, we know that is k plus 1 or cubed, right? We know that is k plus 1 or cubed. So, what do we know about this expression here? Oh, it lies between that, right? Because, you know, you binomially expand the thing behind and you realize that this lies between them. Right? Because k is a positive integer, so it has to be in between. Well, then, if this thing is lying between 2 consecutive cube numbers, then how on earth would it even be a cube number, right? That's just contradiction. Yeah, this is quite a nice part. You know, this is quite a nice part of the question, I think. Okay, so this was a nice question too as well in general. I think it's quite analysis, if that's even what. Okay, it's analysis heavy. Okay, analysis heavy, which is quite important in mathematics as well, I think. So. Cool. There you go.